Hello and welcome back to the channel. My name is Pili and I'm a student studying at Sri Venkateswara College of Engineering, Bangalore. In this video, we are going to learn about the concept of test of significance for large samples from the course of Mathematics for Computer Science and Engineering. Let us start with the introduction. The test of significance is a statistical method used to determine whether a sample provides enough evidence to reject a null hypothesis based on population parameter. It evaluates whether the observed sample data significantly differ from the expected value under the null hypothesis. Now let's see why it is important. For large samples, that is n greater than 30, these tests leverage the central limit theorem to simplify the analysis by approximating the sampling distribution to a normal distribution. If we look into real world application in manufacturing industry, it ensures quality control by verifying whether the produced item meets the specified standards. In medicine, it compares results to assess how well new medications or therapies work. Companies can access if changes in customer behavior are statistically significant by using market analysis. Advantages with large samples. The central limit theorem states that for large samples, the sampling distribution of the sample mean will converge to a normal distribution, regardless of the population distribution. This allows us to use computationally efficient statistical tests like the Z-test. Moving on to hypothesis testing basics, we have significance level, null hypothesis, and alternative hypothesis. The null hypothesis is a default assumption that there is no effect or difference in the population parameter being tested, whereas alternative hypothesis contradicts the null hypothesis, indicating a significant effect or a difference. The significance level is the probability threshold for rejecting the null hypothesis. It represents the risk of committing a type 1 error, that is, rejecting the null hypothesis when it is true. 5% and 1% are the common significance level. For better understanding, you can refer the flowchart depicted here. Now let's know more about the Z-test. The Z-test is used to determine whether a sample mean significantly differs from the population mean when the sample size is larger than 30 and the population standard deviation is known. The formula used for solving any Z-test problem is x bar minus mu bar divided by sigma divided by root n, where x bar is the sample mean, mu is population mean under the null hypothesis, sigma is population standard deviation, and n is the sample size. Now, to solve any problem related to z-test, we need to follow the steps mentioned here. First, define the hypothesis. Null hypothesis assumes no difference or effect, whereas alternative hypothesis suggests a significant difference. Then choose significance level. The common significance level are 1% and 5%. Then calculate the Z static by using the Z test formula. Then compare to the critical value. From Z tables, find the critical value corresponding to the chosen significant level. For example, for a two-tailed test at the 5% significant level, the Z critical value is plus or minus 1.96. Finally, conclude the problem. Check if the Z value is greater than the critical value. If it is, then reject the null hypothesis. And if it is smaller than the critical value, then null hypothesis will be accepted. We have a simple problem here, which states that a machine is designed to produce rods with a mean length of 50 cm. A sample length of 100 rods is taken and the sample mean length is found to be 49.5 cm with a standard deviation of 2 cm. Test the claim that the mean length is 50 cm using a significance level of 0.05. Now you can try out this problem on your own by following the steps we learned in the previous slide. Let us look into some applications and limitations of test of significance for large samples. Starting with the applications, we have quality control in manufacturing. Hypothesis testing is widely used to verify whether the products meet the required specification or whether the manufacturing process is stable. For example, checking if the average weight of produced items matches the desired weight. Example, a company may use hypothesis testing to ensure that the mean length of manufactured rods is within the specified tolerance limits. Next is testing drug effectiveness in medicine. Clinical trials often involve testing whether a new drug significantly improves patient outcomes. A hypothesis test can help determine if the observed effect is statistically significant or if it could have occurred by chance. For example, testing whether a new drug reduces blood pressure more effectively than the current treatment. Next is market analysis in business. Businesses can use hypothesis testing to assess whether changes in their marketing strategies lead to statistically significant changes in customer behavior. This helps inform decisions on pricing, advertising, and product offerings. Example is analyzing whether a new advertising campaign significantly increases sales. Moving on to the limitations. For the z-test to be valid, the sample size should ideally be greater than 30. This ensures the central limit theorem can be applied, which makes the sampling distribution approximately normal. Small sample sizes may not meet these conditions, leading to inaccurate results. The solution for this problem is for small samples, alternative tests such as the t-test may be used. Now, what if the population standard deviation is not known? The z-test assumes that the population standard deviation is known. In many real-world situations, population standard deviation is not known, which limits the direct application of z-test. The solution is if the population deviation is not known, use the t-test, which estimates the population standard deviation from the sample. Moving on to the conclusion, hypothesis testing is a core concept in statistics, allowing us to make informed decisions based on the sample data. It helps to determine whether observed differences are statistically significant or if they could have occurred by chance. For large sample sizes, the central limit theorem ensures that the sampling distributions of the sample mean approximates a normal distribution, allowing the use of z-test. This provides a reliable method for statistical inference in many real world scenarios. Thank you so much for your time and attention. I hope you found the video informative.